Before starting with the implementation of the application, it's worth taking a few moments to discuss the application stack. Understanding the application stack will help you understand the role of each of the components that you'll see going forwards. In this section, we'll put together the web application stack on which we'll build our application. Building the web application stack involves installing several components, and in this lecture, I will first give you an outline of the web application stack and explain what these components are. At this point, we've set up the Raspberry Pi with an operating system that is Raspbian Stretchy Lite. And our operating system also comes with two versions of Python, Python 2 and Python 3 built in. We can connect devices such as the DHT22 sensor and read values out of it, also read the status of a button and control an LED. What we'd like to do next is to learn how to use the web as an interface for the Raspberry Pi. This way, we'll be able to control functionality on the Raspberry Pi via a web browser. To do this, we'll create something called the web application stack. At the bottom of this stack is the hardware, which in our case is the Raspberry Pi. On top of the hardware, we've got the operating system, which is Raspbian Stretch Lite. The operating system gives us access to the resources of the hardware. On top of the operating system, we've got a small Python web microframework called Flask. Flask specializes in making it easy to create simple web applications so that we don't have to repeat a lot of work that is common between web applications. So for example, how to receive a request from a web client like a browser, how to construct a response and send it back to the browser. Things like that, which are very, very common in web application, Flask puts together in a very, very simple API that we can use and build our application on it. Our application and Flask are both written in the Python language. We don't expose our application directly to the user and to the user's web browser, but on top of it, we've got what's called an application server, which is UWSGI in our case. UWSGI is a link between the actual web server and our Flask application. Think of it as the interface. The web server that we'll be using is called Nginx. It's a very popular web server. It's fast, it's got a small memory and disk footprint, and it's very popular for running on small computers like the Raspberry Pi or on virtual machines because of its low memory requirements. So Nginx is ideal for our situation. Nginx is responsible for exposing our application to the web, to the internet. It's a one that the user's web browser will make a request for a particular web page. When the Nginx web server receives such a request, it will pass it on to UWSGI, one level below it, and then UWSGI will in turn pass that request over to our Flask application for execution. Then the opposite thing will happen. Our Flask application will respond to that request, pass the constructed web page up to the UWSGI application server, which in turn will pass it directly to Nginx and then to the web browser. You may be thinking of why go through all the trouble of doing this instead of just getting the web browser to pass its request directly to our web application and on Flask. And the answer there is that the Flask application framework does not contain a web server. It only provides an infrastructure for building an application. Similarly, you might be asking, why don't we get the web server Nginx to pass its request for service directly to our Flask application? And the answer there is that because Nginx doesn't know how. It needs UWSGI to interact with the Flask web server because UWSGI is built for that. UWSGI knows how to interact with Python applications and with Nginx, and it can connect the two. The components that I've got enclosed in this orange box are operating on a localized installation of the Python programming language, which we call the Python virtual environment. Think of the Python virtual environment as simply a Python installation that is separate from the Python that comes with the Raspberry Pi and is dedicated to our application. Only our application is using the Python that is installed inside the Python virtual environment. And that gives us a lot of flexibility as to how we configure this dedicated version of the Python programming language. I have another lecture following this lecture to have a closer look at the Python virtual environment and explain why I'm using it in this case instead of simply going with the default Raspbian Stretch Lite version of the Python programming language. Let's have a look at an example of what happens when the user decides to check out the current temperature and humidity in our lab. The user will go to the web browser, will type in the URL for our web application in the URL box of the web browser. The web browser is going to send that request, which is going to go first through the web server. The web server will detect that this is a page that is constructed, put together by our Flask application. So the web server will pass that request over to UWSGI, and then UWSGI will execute our Flask application so that it can calculate and construct the response page. And our web application is going to do just that. It will grab a reading from the DHT22 sensor, put the response page together, and then pass it through UWSGI and then through Nginx back to the web browser so that the user can see the values that they requested. In the next lecture, I will talk a bit more about the Python virtual environment, what it looks like and why we need it. And right after that, we'll start installing the individual components that make up this stack. Just remember that the exact order by which you install these components doesn't really matter, because eventually, once we have them all in place, we'll configure them via configuration files to work with each other. So it doesn't really matter whether you install Nginx first and then Flask and then UWSGI, or UWSGI first, then Flask, and last Nginx, because at the end, as I said, we'll be using the various configuration files to make sure that all of them work together. Another component that I haven't shown here, just to keep things simple, but that we will be using, is a database. I've chosen a simple database called SQLite 3, which will be installed similarly to Nginx on the server operating system and will be available not just to our web application, but to any application on the operating system that requires database services. So let's continue next with a look at the Python virtual environment. Then we'll continue with installing and doing a little bit of testing on the Flask micro web framework. Then we'll look at Nginx. Following that, we'll look at the UWSGI. Then we'll get UWSGI to start automatically when the web server, when the Raspberry Pi restarts. We'll install the database, and then after that we are ready to start building the application. As I explained in the previous lecture, all of the components of our web application stack that depend on the Python programming language for their operation will operate using what's called the Python virtual environment. And in this lecture, I'd like to explain a little bit more what this Python virtual environment is and why we are using it. The Raspbian operating system comes with what's called System Python, actually with two versions of Python, Python 2 and Python 3, with basic collection of modules and packages. And of course, we can use this Python to run our application. So we can run as many applications as we like. Some of those applications can be web applications, some others can be console applications, and of course you can also create graphical applications on Python using frameworks such as the tkinter GUI Python application framework. The problem with this setup is that the system Python and its collection of modules and packages must have a single configuration, a single setup that can allow for all these applications, there could be multiple, to operate. So for example, if application 2 requires a particular module, then we need to install that module at the system level Python, and then that module will also be available to all other applications. Now, if we happen to have, say, 2 modules that are needed by 2 different applications, and those modules for some reason are conflicting with each other, perhaps they have the same name, for example, but there could be other reasons for such conflicts, then things are becoming a bit tricky. We'll have to figure out and spend a lot of time trying to troubleshoot what is the cause of the conflict, and then fix it if we want both our applications that need those 2 different conflicting modules to be able to operate. So that's too much headache in my opinion. An alternative is to use what's called the Python virtual environment. Again, there is the system Python with its own basic collection of modules and packages, just like on the case on the left side of this diagram. But let's say that we want to install and operate an application, let's call it App 1, that has a specific set of requirements in regards to the version of Python that it needs and the exact collection of modules and packages. Then what we can do is to give it that exact set of Python requirements. We'll give it a dedicated installation of Python at the exact version and at the exact collection of modules and packages. If another application also has its own specific requirements from Python, a specific different version, specific collection of modules and packages, then again, we can give application 2 its own version of Python with that specific set of modules and packages. And the same thing goes for application 3, its own Python, and any other application that we decide to use. So when our applications at this time using their own Python virtual environments evolve and the needs from the Python installation change, we will simply go to their dedicated Python virtual environment, make the necessary changes to the environment's Python installation and configuration, and our application will be then continue to use that dedicated version of Python without any conflict, without any issues appearing in any of the other applications' dedicated Python installations, since they are all separate and they're not dependent on each other. We'll still have the system Python. We use the system Python to help us set up the individual dedicated Python virtual environments, but other than that, system Python is not going to be used at all to operate our multiple applications here. So you can see that the situation on the right side caters for a lot of simplicity when it comes to running multiple applications on a single operating system and making sure that each application has its own Python optimized for it. And as I said, that involves things such as the exact version that we need, the exact version of Python that we need. Could be Python 2, could be Python 3, it could be Python 3.4.6, for example, with the specific set of modules and packages. And because they are all separated to each other, the setup of each virtual environment will not conflict with any other virtual environments. Hopefully this has given you a much better understanding of what the Python virtual environment is and why we are using it instead of just going with the simpler option of using System Python. After all, our operating system will really only execute a single Python application, the one that we are building as part of this course. So going with a clean virtual environment based Python for each application makes complexity a lot more manageable going forwards. Let's move on to the next lecture now, where we'll set up the Python virtual environment for our application. First, we need to prepare our operating system to compile the Python programming language from the source code that we'll download later. We need to install a set of essential packages and support for things such as SSL support for PIP and support for the compiler and things of that sort. So let's go ahead and do that first. I'm going to prepend all my instructions with sudo because these commands require root access. So sudo apt-get install. Let's install the build essential packages first. It's all done. Next, I'm just going to copy that because it's a longer set of instructions, and you can download those as well from my quick guide. Yes, install those. Next, we'll install another set of packages. So apt-get was unable to fetch a few archives, so let's follow its advice and do a sudo apt-get update to try and fix that. This is probably a problem with my own connection rather than the tool itself. Yes, let's try again. Okay, that's better. So those prerequisites have been installed successfully now. Next, let's install the Python development tools. So I'm going to copy this instruction in and hit enter. Another 32 megabytes of archives to download. Okay, done. So the Python development tools have been installed. We've got one more set of packages to install, and that is the set of packages necessary for SSL and TLS support for PIP, which is the Python package manager that we'll be using later on to install Flask. So if you don't install libSSL, dev, and OpenSSL, you won't be able to install Flask, which is a major component of our stack. So let's go on and do that as well now. Awesome. So now that we've got our SSL TLS support for PIP, let's continue with upgrading the System Python 3 installation. The first thing that I'd like to do before setting up the Python virtual environment for the application is to update the version of Python that the Raspbian Stretch Lite OS came with. So I'm going to do this in this lecture. let's log on. And logged on as the user Pi and at the root of my home directory, I'm going to create a new directory to store the source of the Python language, because we'll be downloading the source code of the latest available version for the Python 3 programming language, then compiling it before we install it. So here we are. I've just created a new Python directory, which is this one here, and I will go in it like that. At the time I'm recording this particular video, the latest available version of Python 3 is 3.6.4. You may want to know what is the latest available version of Python when you are actually following this course. So to do that, go to the python.org website, then go into downloads. And here you'll see what the latest available version is. In my case, as I said, it's 3.6.4. In your case, it could be a newer version past that. If you scroll down, you'll see there are specific releases of the Python language that you can get. But I just go for the latest available version. So once you have the information of the Python version that you'd like to download, the next thing to do is to download the source code. So to do that, we'll use the wget utility. And I'm going to copy the location of the archive that contains the version of Python that I want to get. So it's https www.python.org. We'll go into the FTP folder, Python folder. This is a specific version that you'd like to download, and this is the archive. So hit enter, and the download process will begin. So this is a fairly long process. In this case, it's going to take about 10 minutes in my case to download. So let's pause here, the recording, and resume in about 10 minutes. Okay, so the download process of this source code is complete. It was a 21 megabyte download. Let's check out the contents of our directory now. And here's the archive that contains the source code. Before I go on to extract it and compile and then install this updated version of the Python programming language, let's check out the current version of Python 3. So I'll just say Python 3 with the version parameter. And you see that right now it is Python 3.5.3. So once we finish with the installation process and the update process, we'll have Python 3.6.4 installed at the system level. Next, let's extract the contents of the TGZ archive. To do that, we'll use the tar utility. So tar zxvf, and then the name of the archive file. Okay, so now we've got a new directory called Python 3.6.4 that contains the source code. Let's go inside this directory. And inside here, we've got a bunch of files that include the source code for the Python language, but a few files that will help us set it up as well. So the first one that we'll use is the configuration file, configure script. So we're going to execute the configure script, and we'll give it a prefix. The prefix is the location on the file system where we'd like to install this version of Python. So we want to put it inside usr local opt, and we're going to call it Python 3.6.4. So this is going to do a little bit of work to prepare the new version of Python for compiling it in the next step. Great. Configuration completed. The next thing to do is to compile it. So to compile it, we'll use the make script. So type in make and hit the enter key. Now this is going to take a while. The compilation process is a bit of time consuming. It will be much faster on a Raspberry Pi 3 versus a Raspberry Pi 2. So let's leave this alone for the next few minutes and continue when the compilation process completes. Okay, so a while later, in my case it was about 15 minutes later, the make utility has completed compiling this newer version of the Python programming language. Now, somewhere in this output, you should see a message saying that Python has finished successfully, the Python build finished successfully. And you may need to scroll up a little bit. And in my case, here it is. This is the message I was looking for. If you've got that message, then you can go ahead, and if you got that message, then you know that the compilation completed successfully and that you have the Python 3.6.4 binaries ready to be installed. So the next and last thing to do is to install your new Python version. Because we want to update the system version of Python, we need to execute the next command as superuser. So we'll type in sudo, and then to do the installation, say sudo make install and hit enter. Okay, so at the end of this copying process, you should have a message like this. So collecting setup tools, collecting PIP, installing setup tools and PIP, which we'll be using later as well. And then eventually the process will finish. It will say successfully installed. Let's check out that we have Python 3.6.4 installed in the location that we specified earlier in the configuration step. So to do that, we'll say usr local opt Python 3.6.4. Now the executable for this Python is inside the bin directory, and inside here we should have Python 3.6. So use the version switch to check out the installed version, and you can see that it's 3.6.4, which is what we just installed. You can also try out getting the version for Python 3, and you can see that the original version that the operating system came with, 3.5.3, is still there. So we didn't actually override the original version, we just installed the Python 3.6.4 alongside 3.5.3. And that's perfectly okay. You can have multiple Python versions, one right next to the other in parallel. But now knowing that we've got an updated version of Python, we'll be able to use that specifically to create the virtual environment for our web application. Now, because we'll be using Python 3.6.4 just to create the Python virtual environment for our web application, we don't really need to put its executable, its binary file in the search path on the command line. We will simply use the full path on the command line in order to execute it and to use it like that. Because installing the latest version of Python on Raspbian takes so long, so there's a long process to download it, then to compile it and install it, I recommend that at this point you take a backup of your setup so far before continuing to the next step, where we'll set up the Python virtual environment for our application. In the previous lecture, we completed the installation of the latest available version of Python 3, which is Python 3.6.4. In this lecture, we'll start setting up the infrastructure for our web application, and the first thing to do is to create a new directory for our web application and install the Python virtual environment in it. This is something that we need to do as root, and for this you can either log out from Pi and then re-log on as root, or simply use sudo su if you are already logged on as Pi to continue your session as the root user, which is what I've done here. So just type in sudo space su, and that will allow you to switch user and become root to continue this session as. We will install our application directory inside the var directory, which exists in the root of the Raspbian file system. So type in cd space /var, and I remind you that cd stands for change directory. That's how we can move around the Linux file system. So inside var, there's a bunch of directories. There's no www World Wide Web directory in which I'd like to install the directory for our application. So let's create it. We can use the make mkdir make directory www. And now we've got a new directory called www, and you can see that this directory is owned by root. This first user is the owner of the directory, and this is the name of the group to which this user belongs to. I use the name www for this particular directory because I just want to keep things tidy, and I'd like to keep the directories for all web applications inside the same place, so that when I see www, I know that it is a directory that contains subdirectories that make up web applications. So having done all that, let's move inside www, which is empty, of course. Just clear the screen, and then inside www, we'll create a new directory called lab app, since this is the name I'd like to give to my application. You can name your application anything you like, but if you change the name, just beware that you'll need to make some adjustments to the various files that we'll be creating later. All right, so now we've got the lab app directory inside www. And let's move inside the lab app directory, which is empty. Next, let's create the Python virtual environment and install it in the lab app directory. Remember that we installed the latest version of Python inside USR, local, opt. It was Python 3.6.4, and all the binaries are inside the bin directory, binary, and then we want to invoke Python 3.6. Well, this is the executable that we can call in order to execute Python 3.6.4, and I would like to execute a particular module that is part of the Python 3.6.4 installation, which is called venv. So that's what the M switch stands for. So with venv, by executing the venv module, I am able to install a Python virtual environment at some arbitrary location in the file system. And I'd like that arbitrary location to be my present directory. That's what this dot is about here. The dot in the Linux file system indicates the present directory. Instead of dot, I could have also said this. Like that, and they would have had the same effect, but just simply using dot as a shortcut has got the exact same effect. So hit enter, wait for a few seconds. This should be fairly quick. So the venv module is copying the appropriate files and directories inside the lab app application directory, and now we should be able to see there's the new content. There is the bin directory that contains the executables and utilities for the virtual environment and a few other files, like this is where the libraries will go. If I have a look inside the bin directory, you'll see that there's a bunch of files as well, including Python 3.6. And you can see that the Python 3.6 is a pointer to the location where we earlier installed Python 3.6.4. So the executable is shared, but everything else, including configuration files and libraries, you can see here, are dedicated now to my lab app application, and they are not shared with any other application. If I have a look inside the lib directory, you can see there is a special directory here that contains libraries for my virtual environment dedicated to my application, not shared with anything else. However, my Python version is still the system version. In order to actually use the version of Python that comes with the Python virtual environment, I need to activate it. And to do that, I need to execute. In this context, the dot means to execute an executable that I specify in the command line, which is bin and activate. So now notice that I've got an indicator on the command line saying that I have activated the Python virtual environment in this location. And if I check to see which version of Python am I using, you'll see that the version is now 3.6.4, which is the version of the Python virtual environment instead of 2.7.13, which was the system Python that I was working with earlier. So remember that every time that you enter the directory of your application, you need to first activate the virtual environment like this before you can start using it. If you'd like to stop using the version of Python that comes with your Python virtual environment and go back to the system Python, then you simply type deactivate. And you can see now that there's no lab app showing at the beginning of the command line, and you're back to using Python 2.7.13, the system Python. Now that we've got the Python virtual environment set up, let's move on to the next lecture where I'll show you how to install Nginx and Flask. In the previous lecture, we created the directory in which we'll install our web application, and in the directory we installed the Python virtual environment. In this lecture, we'll start by installing Nginx, making sure that it works, and then installing Flask, and we'll create a very simple Flask application example as well and make sure that we can see it in the web browser. So let's begin with Nginx. Notice that I'm still logged in as root, and before I forget, I will activate the Python virtual environment. And there we have got the Python virtual environment now activated and logged on as root. To install Nginx, we'll use the apt-get tool. So I'll type in apt-get install Nginx. That should be fairly quick. It's not a very long installation process. Down here, I've got a complaint from apt-get saying that it was unable to fetch some archives, and maybe I should run apt-get update. So I think that's a good idea. So let's try it out. Apt-get update and see if that will resolve the problem here. And this time it worked just fine. Now, Nginx was installed and it's actually already operating. So to confirm that, just bring up a new browser window and navigate to the IP address of your Raspberry Pi, .36 in my case. And that's how you know that your Nginx installation was completely successful. You'll get the Welcome to Nginx page. Now that we've got Nginx installed, the next thing to do is to install the Flask Python micro framework on which we'll build our web application. To do that, we'll use the pip utility, the Python package manager, and install Flask. Downloading Flask and a few of its dependencies. And that's it. We've got Flask installed inside the application directory under the Python virtual environment. Let's try it out. What I'd like to do next is to create a tiny little application. I'm going to use Vim and create a little application. Let's call it hello.py. And in here, I'm going to copy the code that will give us the smallest possible Flask application. I'll paste it in, just kind of fix some issues with indentation. Put it back there and make that there. All right, and indentation should be good. I'm going to give some spacing here. I'm going to talk more about this Flask application in the next lecture. I just want to make sure here that our Flask installation works. And all I want to say at this point is that when this application is running in just a minute from now, I'm going to be able to go to my web browser and call this resource, the hello resource, and my browser should show this message back. So let's save it. So write the buffer to the file system and quit Vim. And then I'm going to use Python to execute my hello.py program. Right, so you can see that now my little web application is running and it's waiting for connections at port 8080. So I'm going to bring up a new browser window and navigate to the IP address of my Raspberry Pi, and at the end I'm going to specify port 8080. And there is my little hello world message in the browser, and you can see that the GET request from my web browser was captured by the application, and you can see that it reports that on the command line. Great, let's move into the next lecture now, where I'd like to drill a little deeper into this very simple Flask application. At this point, we've got Flask set up in our virtual environment inside the application directory. And in the previous lecture, we executed a very simple Hello World program just to be sure that our Flask micro framework is actually working. And you can see here that it is. I can hit the application with a GET request from a web browser, and the application will respond and send back this little message, hello world. In this lecture, I'd like to have a look at this very simple code that makes up our application and get an understanding of how Flask works, just using these few lines of code. So I'm going to put this away for now, and I'm going to hit Ctrl+C to stop the application, and then go inside Vim hello.py to have a look at what's going on in here. You can access the Flask documentation here at this location, flask.poku.org. You can look at the table of contents and access the various bits and pieces that make up Flask. but the quick start guide contains a lot of details about how this minimal application works, but I'm going to give you the condensed version from this. Our little script begins by importing the Flask module. In the second line, we create a new object from this class that will actually consist of our working application. Many people get confused by this expression here, the underscore name underscore. This is actually quite simple. This is a variable that is set up when a new Python script is being executed. And you can see that the same variable appears down here. It's just a variable, therefore it's nothing fancy. Python will assign a value to this variable, and this value depends on how the Python script is being executed. When the Python script is executed directly, I'm going to go back, quit and exit. So when I do this, hello.py, what I've just done is to execute the script directly on the command line. When this happens, then let's exit, and actually this time I'm going to use cat so we can have both expressions visible here. So when I actually execute this script on the command line like this, then Python will assign the value underscore main to this variable, like what you see right here. So indeed, the variable underscore name will be equal to the value underscore main when I execute my script directly on the command line. And when that happens, then the application that I just created up here, which is an instance of the Flask class, will be run. So Python will call the run function of this object and will pass these parameters, and then it will execute my application. And that's how I'm then able to access it from another computer, in this case my PC, on a host that is outside my Raspberry Pi server. Now hold that thought for a minute. I'm going to come back to this and give you an alternate example. I just want to continue for another minute with what is happening in the rest of my little program here before I come back to what is happening in these two lines. Another very important aspect of my application are the routes. This line here that I've got highlighted creates a route that is at the root of the URL that my browser is calling when it's hitting my Flask application. And what it's saying is that when the client is requesting the root of the URL, then it should execute this function here. And this function simply returns hello world. Now let me give you an example of how I can create a different route. I'm going to go back into Vim and edit my little program here and add another route. So let's say that I'd like to have a second route and call that example, close parenthesis, and I should add the / at the beginning of example, so that now I'll be able to call my program in a route that looks like this. Let's continue with creating a function that will return some text. So here I can just say example route. I don't need to pass any arguments at this point, and return something like this is an example route, or whatever else you'd like to put there. Just notice that the name of the function here doesn't need to match the name of the route, but it can. So if I wanted to keep things simple, I could just do something like this, but it doesn't have to be. So I'll just go back to the original. I'm going to write the buffer to the disk and quit Vim, and execute my program again. And let's go back to the browser and just hit enter. So there you go. So now we call the example route. You can call back the root. There's a root. Let's go back to example. There's the example. So now hopefully you're starting to get an understanding of what these routes are and how you can create an application that allows you to have multiple available pages to implement different aspects of the application. Now, the next thing that I want to show you while I'm here is what happens if these last two lines are not there. So what I'll do is I'm going to comment them out. Just a sharp symbol here is used to comment out any code in Python. So I'm going to write and quit and clear the screen. And let's try to execute the script now. Nothing actually happened. The application actually didn't run because I did not call the run function. Let me show you again. The application didn't run because I didn't call the run function of the app object, the Flask object that we call app, that is defined up here in line 2 of my small application. So I can still execute a Flask application on the command line and manually call its run function. And I can do that like this. Flask, this is how I'm calling the run function, and I can hit enter. And you can see that now by default, this application is running here on this port 5000. Let's see, can I still call it from my PC, from the external host? No, it says I can't connect to the server. That's because I did not permit for this application to be accessible from outside the server itself. So to do that, I'll just quit out. I need to specify that the host is 0.0.0.0. And now I'll be able to access it on port 5000. Let's try that again. On port, I made a mistake here. On port 5000. There you go. I can also, of course, change the port number by using a different switch, a different parameter, sorry. This is called port. And let's say I can make that port an arbitrary 1, 2, 3, 4. And let's change the 5000 into 1, 2, 3, 4. There you go. That works. And both routes also work like that. So let's quit. Let's go back to Vim. As you can see, these last two lines are there for convenience so that we can execute the Flask application on the command line, and without having to type any configuration parameters on the command line, we can get the application to be available from hosts outside the server and on port 8080, which is probably easier to remember than say 5000, because the default port for a web application is 80, and we can make this run on 8080 because later on we'll be configuring our main application to be available on port 80. So I'm going to remove the hashes now to re-enable these last two lines. Now, because later, very soon in the next lecture, we'll be configuring this application to be controlled by UWSGI, we only want this configuration to be enabled when we are executing the application on the command line. And that's why we've got this if statement here. This statement ensures that the application will run and will be available on port 8080 and for external hosts only when we are executing it on the command line. In the next lecture, we are going to configure UWSGI to take control of how the application will be accessible. So we don't want our program to define that information and have it hardwired inside the application script. Instead, we want to configure this inside the UWSGI configuration file. And that's why when the application is invoked from another module, not on the command line, this line will not be executed. It will be totally ignored because the __name__ variable will not be equal to main. Before we finish with this lecture, just wanted to invite you to have a look at a couple of pages of documentation. The first one is here on docs.python.org for version 3 of Python. I'd like you to have a look at this very small page just to get a better understanding of what this value means. And then I'd also invite you to read the quick start guide for Flask on flask.poku.org. At this point, we have a very simple Flask application, and we can execute it on the command line and access a couple of routes on a web client on a different host. In this lecture, I'd like to install the UWSGI application server so that it can control our Flask application instead of us doing that directly on the command line. And remember that once we have UWSGI properly working and configured, we are going to connect it to Nginx so that our web client, our web browser, will be able to request a Flask application resource via Nginx, and then Nginx will pass that request to UWSGI to retrieve that resource on our behalf. So let's begin first by installing UWSGI. And remember that we are logged on as root and we have enabled the Python virtual environment. So to install UWSGI, we'll use the pip utility and type install UWSGI. Great, so we've got UWSGI successfully installed. We can double check that that is so by having a look inside the bin directory, and in here you'll see that the UWSGI executable also now exists alongside the other executables. The next thing to do is to create a new configuration file for Nginx in order to replace the default configuration file. The default configuration file for Nginx is the one that allows us to hit the root of the URL for our web server at port 80 and gives us this message here. So we want to remove the configuration file that gives us this result and replace it with one that gives us access to our Flask application. The default configuration file for Nginx looks like this. So I just scroll up again. I did this too fast. You can go to etc nginx sites enabled and default, and then this file exists there that contains basically the very basic configuration for our default website that is available on Nginx when it's first installed. But I am going to delete that by using the rm command. So remove etc nginx sites enabled default. Now I'm going to create a brand new configuration file for Nginx, and I'm going to use Vim for that. I'm going to store this file inside the lab app directory just to keep everything tidy in one place. So I'm going to call that lab app for nginx.conf. Be very careful not to make any typos here because we'll be using the exact same configuration file name in our UWSGI file in a minute. So create this file, and then inside this file, I'm going to copy a bit of code like that. So a couple of things to notice. First of all, our Nginx website will be listening to port 80, the default port for web applications. Server name doesn't really matter, character set, it's all standard stuff. We are also setting a place for static files which involve things such as CSS files and image files and things of that sort. They will be storing inside a directory that doesn't exist yet. We'll create it a bit later, called static, which exists inside the lab app directory. So this is just provision for us to put in static files as we are building the website for our application a bit later. What is very important here is this clause here, and especially this. This is a socket file, and it consists of the means by which UWSGI will be able to communicate with Nginx. So any information that, any data that is exchanged between the UWSGI and the Nginx processes will be happening via this socket file. It's just a file that will exist inside the application directory. So let's write this file onto the disk and quit Vim. We're not done yet. We now need to provide a symbolic link between the file that we just created and the site's enabled location on the file system where the Nginx process is looking for its configuration files. So we need to link this file inside this directory. And we can do that by creating a symbolic link instead of copying the file itself into the site's enabled directory. In Linux and Unix, we can create symbolic links by using the ln command and give it the s switch. So we need to create a link between this file, and we want that symbolic link to go to etc nginx conf d, just like that. And now we can double check that the symbolic link has been created. We'll just do a long listing inside etc nginx conf d, and inside here you'll see that we've got the symbolic link created. So now that we've got the Nginx configuration file linked into the confd directory, which has got the exact same effect as if it was linked into the site's enabled directory, we need to restart Nginx in order for this configuration change to take effect. So we can restart Nginx like this. Say etc init d Nginx restart. Okay, so the Nginx process restarted and loaded the new configuration file. Okay, so the Nginx process restarted and loaded the new configuration file. We also need to create the configuration file for UWSGI. So let's do that now. So again with Vim, we'll say Vim lab app underscore UWSGI dot ini. And in here, I'm going to copy the configuration. That looks like this. So we've got the UWSGI header up the top, and then we define the base location for our application, the name of our application. Remember, the file name for the file that contains our Flask application is hello.py, so the name of the app is hello. We copy that same name as the name of the module. Then we define home and the Python path. Python path indicates the fact that we'll be using the Python virtual machine to execute our Flask application instead of the system Python. And here we define the %n switch that is simply a placeholder. This will be replaced by the actual name of the file that we created. So in other words, you can have a look at the documentation here at this location for UWSGI. So UWSGI docs.readthedocs.io, etc. You can see the short URL on the screen right now. And down towards the bottom, you see there's a big table with a lot of different switches that are possible inside a UWSGI configuration file. And one of them gives us the file name without extension. That is the %n. So instead of repeating ourselves, we'll just say %n. Instead, of course, we could have written here the full name of the file name, lab app UWSGI and .soc. That would make up the name of the socket file. And remember that this is the exact name that we also used inside the Nginx configuration file as the place where it can communicate with UWSGI. So this line here has to match exactly the configuration for the socket file that we used inside the Nginx configuration. I'm going to put the placeholder back here. There's also a log file down here that we define. We have to create the log directory UWSGI in here so that this file can be stored. We'll be using this file to debug our application whenever something breaks and we want to figure out what the problem may be. Then we'll go to this log file to look for clues as we are doing our debugging. We get the opportunity later on to work with this file as well. Let's write, so I'm going to hit escape and write this file to the file system and quit. Next, we need to create the directory in which UWSGI can store its log files. So remember that down the bottom here, we've specified that location to be here. So let's create this directory. Make directory var log UWSGI. And now there is a location for the log files. To test all this out, we will start UWSGI manually on the command line. So that is done like this. So bin UWSGI and the initialization file or the configuration file, we need to provide the full path to that. So lab app and then lab app UWSGI ini. UWSGI is grabbing the information and configuration information from the ini file. And let's go and check out that the default application from Nginx, the one at port 80, now hits our Hello World application. There you go. So no need to specify a custom port number. What about the example route? That is also working. Awesome, that's great. What we have now is we've got a very simple UWSGI Flask application that we can access via Nginx on the default port 80 for web applications. And at this point, I also advise you to take another backup of your setup. So switch off or shut down your Raspberry Pi, remove the SD card, plug it into your computer, and take a backup at this point, as you've learned in earlier lectures. Now, one thing that we want to be able to do is to make sure that when our Raspberry Pi restarts, that the UWSGI process also starts automatically, because at the moment, remember that we had to start it manually. If your Raspberry Pi restarts, then the UWSGI process will not actually be operating. And in that case, when you try to hit your web application, you will get a 502 bad gateway. In order to not have to go to log on as root and manually start UWSGI, we need to make that restarting automatically, and we'll do that using a built-in process manager called systemd, and we'll do that in the next lecture.